Hi everyone, I am Erica Santos, a grade 11 STEM student, and I am here in front of you to discuss about separating mixtures. So before we start, may I ask you all, what is separating mixtures? Separating mixtures is a physical combination of different substances. The substances involved does not undergo chemical change. In fact, the properties of each substance are still recognizable. If this is the case, therefore substances that makes up a mixture can still be separated from each other through a physical means. There are 12 different methods of separating mixtures. The first is decantation, the second is filtration, the third is centrifugation, the fourth is solvent extraction, the fifth is distillation, the sixth is crystallization, the seventh is sublimation, the eighth is fractional distillation, the ninth is melting, the 10th is chromatography, the 11th is magnetization, and the 12th is evaporation. Let's proceed to the first method of separating mixtures, the decantation. So what is decantation? Decantation is the process of separating the solid components of mixtures by setting the heavy solid particles and gently pouring out the liquid without disturbing the solids at the bottom of the container. So for example, we have a mixture of a water and a sand. So let's say that the water and the sand is in the basin. So what will you do is, you will pour the water in another basin, but the sand will left behind. That method is what we call as decantation. So I have here a short video clip for you to understand more about decantation.
If we use food coloring, you can see the both layers very clearly.
Let's proceed to the second method of separating mixtures, the filtration. So what is filtration? Filtration, the process of separating small solid particles from a liquid by passing a mixture through a porous medium. So for example, you want to boil a coffee granules because you want to drink your favorite coffee. But when you pour it to your cup, some particles of coffee granules has to generate. For you not to swallow the coffee granules, you filter it with a filter paper and a strainer. That method is what we call as filtration. So I have here a short video clip for you to understand more about this method.
Experiment to separate a mixture of mud and water by filtration. Mix mud and water in a clear glass beaker. We observe that the color of the mixture turns brown. Take a circular filter paper and fold it in half, and then in half again, so that you get a cone shape. Place the conical filter inside the funnel. To use the filter paper, open it up into a cone shape. with 3 layers on one side of the cone and 1 layer on the other. It will form a cone shape. Put another glass beaker below the funnel. Pour the mud water slowly into the cone with the help of a glass rod. Watch it drip through the filter paper and funnel. We observe clear water getting collected in the other beaker placed below the funnel and the mud in the filter paper. The substance that remains in the filter paper is called residue. The clear liquid or the substance that is collected after filtration is called filtrate. This method of separating insoluble impurities or substances from a liquid is called filtration.
Let's proceed to the fourth method of separating mixtures, the solvent extraction. So what is solvent extraction? Solvent extraction is removing a substance from a solid or liquid mixture by adding a liquid in which a substance is more soluble. So I have here a short video clip for you to understand more about this method. Let's proceed to the fifth method of separating mixtures, the distillation. So what is distillation? Distillation, using differences in boiling point as basis for separating liquid mixtures. The liquid with a lower boiling point vaporizes first, followed by the liquid with the next higher boiling point. Distillation. So I have here a short video clip for you to understand more about this method.
When performing a distillation, first the condenser is filled with cold running water. Next, heat is applied to the mixture which is to be distilled. The mixture is heated until it boils, and the hot vapors will travel up the distillation head. Measuring the temperature of the vapors helps us to identify the liquid being distilled and will help to confirm its purity. If the vapors are pure, they will have a constant temperature equal to the boiling point of the liquid being distilled. As the vapors travel into the condenser, they will be cooled and will liquefy. The liquid droplets, called the distillate, run down the condenser and are collected in a receiving flask. A liquid can be easily separated from non-volatile contaminants by using a simple distillation apparatus such as this one. Since the non-volatile components in the distillation flask will not evaporate, the vapors and the resulting condensate will be pure.
Let's proceed to the sixth method of separating mixtures, the crystallization. So what is crystallization? Crystallization: forming a crystalline solid by decreasing its solubility as a result of cooling the solution, evaporating the solvent, or adding solvent in which it is less soluble so that solid crystals form. So I have here a short video clip for you to understand more about this method.
Have you seen crystals of salts? Crystals are made through a process of crystallization. Let us try to make salt crystals from a solution of salt. For this we need thread, a saturated solution of copper sulfate, and copper sulfate. First we will make a supersaturated solution of copper sulfate. Light the spirit lamp, place the copper sulfate solution on the burner, heat the mixture. Now keep on adding copper sulfate till no more salt is dissolved. Fasten a thread on a support and suspend it in an empty glass. This thread will act as a nucleation center in the container. Now remove the solution from the burner. Pour the solution in the glass. Leave the glass aside for a few days. We see salt crystals formed on the string. This happens because the solubility of salt in water increases with temperature of solution, so more salt gets accommodated in the solution than it would have if water was at room temperature. This solution is called a supersaturated solution. The salt from this supersaturated solution gets precipitated out when the solution returns to room temperature. The salt molecules that get precipitated out start forming crystals at the nucleation center, which is the thread in this case. Crystallization is the process of formation of solid crystals of a substance by precipitating it out from a saturated solution.
Let's proceed to the seventh method of separating mixtures, the sublimation. So what is sublimation? Sublimation is the process of changing solid to gas without passing the liquid state. So, for example, a burner and a china dish. The smoke or gas that came from the china dish travels to the funnel and evaporates to the cotton plug. So I have here a short video clip for you to understand more about this method.
Certain materials such as camphor change their state from solid to gas without changing to liquid first. This is known as sublimation. Let us see sublimation in a mixture. For this we need crushed chalk powder, crushed ammonium chloride, a funnel with cotton plugged to its stem, evaporating dish, and a spirit lamp. Mix the ammonium chloride and chalk powder and put it in the evaporating dish. Now place an inverted funnel over the china dish. Heat the mixture. After some time, the ammonium chloride sublimates, that is, changes its state directly from solid to gas, so it gets vaporized while chalk powder remains in the dish. Sublimation is an endothermic change where a substance vaporizes directly from the solid to the gaseous state without passing through an intermediate liquid phase. In this case, not only did we see sublimation, but we also saw how sublimation helps to separate mixtures.
Let's proceed to the eighth method of separating mixtures, the fractional distillation. So what is fractional distillation? Fractional distillation, a complicated process of separating mixtures that also uses the difference in the boiling point of the substances involved in the mixture. For every increase in the temperature, there is a specific substance separated from the mixture. The continuous increase in the temperature results for the evaporation of different substances at a specific temperature. This method is used in purifying crude oil. So I have here a short video clip for you to understand more about this method.
Let's take an example. Separation of acetone and benzene by fractional distillation. As the difference in boiling points of acetone, whose boiling point is 329 Kelvin, and benzene, whose boiling point is 353 Kelvin, is only 24 Kelvin. Their mixture can be separated by the process of fractional distillation, using fractionating column. Let's see how this can be done. The mixture is taken in the distillation flask. Fractionating column is inserted between distillation flask and Liebig water condenser. The flask is heated on water bath. At a steady temperature of 329 Kelvin, acetone distills out, and is collected as first fraction, in the receiver. The vapors of benzene are cooled in the column, and liquid benzene trickles down back into the flask. When acetone is distilled out completely, the temperature starts rising, and the receiver is changed. When the temperature becomes steady at 353 Kelvin, benzene distills out, and is collected as second fraction, in the receiver. Acetone and benzene can be further purified by redistillation, using simple distillation apparatus.
Let's proceed to the ninth method of separating mixtures, the melting. So what is melting? Melting is a process that can be used in extricating mixtures that contain two substances with different melting points. So I have here a short video clip for you to understand more about this method.
We're going to get a melting point of this compound we've just recrystallised. A melting point tube can be made by sealing the end of a capillary tube. Hold the tube at 45 degrees with the end at the top of the blue cone of the Bunsen flame and gently turn the tube. You want to seal the end but not heat it so much that a glass ball is formed on the end of the tube. This will make it hard to insert into the melting point apparatus. The easiest way to get your compound into the melting point tube is to put a small amount onto a watch glass and press the open end of the tube onto the solid to create a small plug in the end of the tube. You can either flick the tube or bounce it gently on the bench to get the solid to the bottom of the tube. You only need a few crystals. Put it into the melting point apparatus and turn the heater to 3 or 4. Don't be tempted to turn it to 9 or 10 as you'll overshoot the melting point and you'll get an inaccurate value. Don't be tempted to use a rapid heat either for the same reason. Watch the solid until you just see it starting to shrink from the side of the tube, and that's the first sign it's starting to melt. You need to take a range of the melting point, so record the temperature at which it starts and finishes melting.
Let's proceed to the 10th method of separating mixtures, the chromatography. So what is chromatography? Chromatography, separating the mixture's components by nature of their differing absorptive tendencies on a stationary phase as a mixture is passed over or through it. This method is used on absorbent filter paper or chromatogram paper. The separation depends upon the solubility of each component in the mixture. So I have here a short video clip for you to understand more about this method.
It's paper chromatography to analyse the inks in biro ink. I've cut a piece of filter paper to fit the beaker and I've drawn a line about 10 millimetres up. I've also made developing solvent which is made from 20 centimetres cubed of water, 20 centimetres cubed of ethanol and 60 centimetres cubed of butan 1-ol. Draw dots of biro on the line. Place the filter paper in a beaker and fill it up with developing solvent so it is just below the line. You don't want to touch the inks with the solvent. You then leave it for about half an hour to let the liquid move up the paper and watch the solutes spread. As you can see, the solutes have now spread according to their solubility in the solvents, and you're beginning to get different colours emerging. So you're getting pinks out of the reds, yellows and greens out of the blue, and purples out of the black. This is the same thing, but instead we've used felt tips to see if we get a greater range of colours.
Let's proceed to the 11th method of separating mixtures, the magnetization. So what is magnetization? Magnetization is the process of separating elemental metals from other particles, which is usually non-metals. So I have here a short video clip for you to understand more about this method.
I'm going to combine two substances, table salt and iron filings. When you combine two or more substances, what is it called? What do you notice? Does the salt still look like salt? Is the iron still iron? How can I separate them back into their lone substances? I'm going to use what I know about the physical properties of salt and the physical properties of iron to separate them back into their original substances. I know that iron is magnetic and salt is not. So
let's proceed to the 12th method of separating mixtures, the evaporation. So what is evaporation? Evaporation, the process of converting a liquid to gas. This is useful in sorting mixtures such as salt solution. So I have here a short video clip for you to understand more about this method.
Aim: to study the process of evaporation. The apparatus required for this experiment is as shown. Click here to take some water in china dish. Click here to start the heating. After some time, water starts to disappear. Continue heating until all water evaporates. Now click the reset button and add spirit to china dish. Do not heat the content and keep it for some time. After some time, all content in china dish will evaporate.
This kind of separating method is what we call the centrifugation. Here's a short video clip of it.
When a liquid containing suspended materials is allowed to stand for some time, the heavier particles will settle down through a process called sedimentation. This can be used to separate the material from the liquid. But what will we do if the suspended material is very light? It will take days to settle. In such cases, we can use the process of centrifugation to quicken the process of sedimentation. Centrifugation is the process of separating substances of different densities from a mixture with the help of a centrifuge. Let us conduct an experiment to see centrifugation. For this we need a handy centrifuge machine, muddy water, mixture of calcium carbonate in water, 4 centrifuge test tubes. Take the sample of muddy water and place the test tubes in the centrifuge machine. Now take the calcium hydroxide mixture in the test tubes and also place them in the centrifuge machine. Rotate the machines fast for few minutes. stop rotating. Remove the test tubes and observe. We see mud particles and white precipitate have settled in each of the test tubes. This is the process of centrifugation. In a centrifuge, as we rotate, the substances experience centrifugal force away from the center, which forces the materials against the wall of the tube. The amount of centrifugal force experienced by any object depends on its mass and the speed of rotation. The components of a mixture get separated because the denser particles are forced to the bottom while the lighter ones stay at the top. So with an increase in the speed of rotation, even lighter materials can settle down. Centrifugation is used in diagnostic labs for blood and urine tests. It is used in dairies and homes to separate butter from cream.
That's all about separating mixtures. Hope that you get a knowledge of what my report is. Thank you. Have a nice day.